Good evening, everyone. A warm welcome to yet another inspiring edition of GCT Talks, where we bring in accomplished alumni to share their experiences, insights, and knowledge with us. Today, we have the privilege of hosting a distinguished leader in the semiconductor and electronics industry, a proud alumna of GCT ECE batch of 1985, and a true leader in the world of technology, Ms. Chitra Hariharan. Ms. Chitra Hariharan is a serial entrepreneur and a techno-commercial leader with an impressive career spanning over 35 years in the semiconductor and electronics domain. She currently leads startup collaborations, university relations, and government affairs at Renesas. She has had two leadership stints at Intel and has successfully built four semiconductor and electronics product startups: Intel Microelectronics, Open Silicon, Concept to Silicon, and SenZopt, all of which had successful exits. Throughout her journey, she has contributed to the development of over 125 semiconductor products and has played a pivotal role in shaping the chip design ecosystem. Her journey is not just about professional excellence, but also about perseverance, adaptability, and a passion for technology. Today, she will be sharing her insights on semiconductors and emerging opportunities VLSI and electronic products. Without a further ado, let's welcome Ms. Chitra Hariharan to take us through her incredible journey and expertise.
Thank you so much for that warm welcome. It's always a great feel to get back to the campus, even if it is virtually, right? So I was just telling before the start of the call that I'm going to be soon visiting the campus, and I would love to meet you all in person as well. So with that, I'll just start. I'm hoping you're all able to hear me. I've kind of closed the thumbnail video over here. Are you all okay hearing me? If somebody can unmute and acknowledge, that would be very good.
Yes, ma'am, we could hear you, ma'am.
Yes, ma'am.
Okay, great. So we are going to be talking today about the emerging opportunities in this semicon VLSI and the field of building the electronic products. So let's kind of focus our discussion more on the chip space and then the product space. And then I will touch a little bit upon my journey as well, and then we will take it from there. Okay. Okay, I am not able to move. What's happening? I'm going to stop sharing and then I'll share again. You're able to see? Because it is not moving.
Yes, ma'am.
Okay, let me see. We can do here. Otherwise, I'm going to ask you, Saurati, to present. This thing. One second, Saurati.
Ma'am, please can you repeat, ma'am?
You're able to see? The foil is moving? You're able to see? You're able
Ma'am,
to
actually, we are not able to see the screen.
Okay. I'm sorry, folks. Let's see. Let's see whether it works now. We tested everything, but we did not test the cursor moving back and forth. You're able to see now?
No, ma'am.
No. 1 second. Otherwise, Saurati, you're going to share. 1 second, let me. Sorry, everyone.
Ma'am, can I
1 second.
start sharing, ma'am?
1 second. I'm just going to, this is the last chance. I'm just going to try.
Okay, ma'am.
If this is not working, I'm going to let you share. Huh? You're able to see now?
Yes, ma'am.
Okay. You're able to see now?
Yes, ma'am.
Okay. 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 Let's see. Okay. So this is where the journey began. Okay. And you're all able to see what this place is? And this is GCT, and you see me over there as well. So this is where the journey started. And then I kind of had a great experience of working with corporates and working with startup world as well as the person introduced, right? I mean, I had the good fortune of running 5 successful startups, and then all the successful, the startups had a good exit as well. So that's kind of the startup journey. And immediately after my graduation, I was part of Indian Telephone Industries, the company that built the telephones. And then those days we used to be building all the chips that gets into today's Chandrayaan and things like that, right? So all the defense and space application chips used to be built either out of ITI or out of Bharat Electronics. I was part of that, building some of the chips. Then I went to Real Chip. Then afterwards, I was part of Intel Microelectronics. Then I was part of Open Silicon and Concept Silicon. So Open Silicon had a successful exit with one of the private equity ventures. And the company got bought out. And if you are aware of sci-fi, right? I mean, Open Silicon got morphed into sci-fi, the RISC-V company today. And Concept Silicon was the next startup that I did, and that got bought out by HCL. And SenZopt was the IoT product startup that I did. And that is in the space of doing a lot of IoT building automation solutions. Then afterwards, I got to Intel back. Now I'm currently with Renesas. And Renesas is a company which specializes in microcontrollers, and we are into both auto and industrial segment. I'll talk about that also in a bit. And after my graduation, I had, after gaining some amount of the industry experience, I did my executive MBA from IIM as well. I represent some of these industry bodies, VLSI Society of India. I am the secretary of VLSI Society of India. I am very associated with India Electronic Semiconductor Association as well. So we'll now talk about the opportunity space, and then if there are specific questions about my journey, I will definitely take. And I was telling someone before you people joined the call that I'm going to be at campus on April 4th as well. So I'll plan to meet you all in person, and then I mean, if there is kind of a roundtable that we want to have or more questions that we need to have in person, I'll be more than happy to address. Okay, so now this presentation, I'll talk more about the opportunities that lie in the space that I'm very familiar with. And then after the discussion, after the presentation also, we can have questions. Okay. So now you all know this picture. This is a very famous picture of how the entire rocket innovation and things started way back in 80. The reason I put 80 is the year that I entered our GCT, right? I mean, and then we've come a long way, and we have now gone already to, this is the Chandrayaan successful mission. This is just to say that we've come a long way, and India is on the move. Everyone would acknowledge this. And there are multitude of events that are really shaping up India and then propelling the India progress, right? Startup India movement, Digital India movement, Make in India movement, India Semiconductor Mission, all, and then the digital public infrastructure that is existing now. This is created at the population scale, right? And we all know about Aadhaar, UPI, ONDC, and Vande Bharat Express, and Bhashini kind of the app. The reason I'm quoting some of these are the drives that are really making India take center stage at the global economy level. And we are sitting at 5th position today. We are progressing really fast to become the 3rd position in the global economy side. Digital payments, we all know that, UPI, none of the digital payment system that we are all enjoying from here in India today can beat across the globe, right? And data consumption, we are the number one. And mobile, our consumption is the highest. We are sitting at 2nd. Startups, we are holding the number 2 position in the global stage. Railways, ours is touted to be the 3rd position. And on the road infrastructure, also we are holding the 2nd position. So all these things clearly say that, India is on the move. We are really in a position to take off at a much faster rate. So what does this mean for us, right? So what this means is electronics and semiconductor opportunity. This is the one which is kind of touching every sector, which is going to be very pivotal for our economic growth. This is strategic importance, and this is the self-reliance that we need to be gaining in this electronics and semiconductor field is the one that is required for India to reach the global numbers that I mentioned, right? And as of 2023, our market share on electronics is 200 billion. See, we are all engineers. We all want to be talking through the data, and that is why I'm giving some of the numbers. These are all industry and analysis-backed numbers, so that you get to see the opportunity backed by the numbers. Okay. So 2023, 200 billion is kind of the electronics market opportunity for us, for India. And just on that, the semiconductor opportunity is 40 billion. And 2030, this is expected to grow to 500 billion. And the semiconductor opportunity is expected to grow to 135 billion. And come 2047, the Viksit Bharat year that we are talking about, the market opportunity is going to be touching 3 trillion just on the electronic product, and on the semiconductor side of it, this is going to be 810 billion. And this constitutes to 5.8% of GDP, and come 2047, this is going to be 10.2% of GDP, is going to give the at least 10 crore employment potential this is going to create. So instead of waiting up to 2047, let's look at the immediate near future milestone of 2030. For 2030, we all know that electronics and semiconductor products are intertwined. Every application, every product that you can think of, right? There are humongous chips that are sitting inside that is making the product, right? So the 200 billion number that I mentioned is expected to grow to 500 billion. And over here, let's assume if this is going to be growing at 33%, right? We are sitting at the opportunity of 166 billion if the rate of growth is 33%, right? And this is near term. We are sitting today in 2025, another 5 years. Just imagine if we need to be unleashing the opportunity of 166 billion, what all we need to be doing, and what kind of the product opportunities that we are seeing is what we will just touch upon. So this is the electronic product side. Just on the semiconductor side, this is a 40 billion opportunity. 40 billion is the India opportunity. And over here, this is expected to grow to 135 billion. Let's assume we are looking at a 33% growth. this again is going to be growing to 45 billion opportunity year over year. Okay, so this is just a glimpse on the numbers just to give you a feel of the opportunity is humongous. Okay, so on the global vision on the electronics and semiconductor, there are multiple places wherein these opportunities reside, right? One is the product opportunity that I spoke about, electronics, chips and ICs. And then on the manufacturing side also, manufacturing side, we all know about the semiconductor mission announcements that have happened and the multiple fabs and the package OSAT, ATMP plants that are all going to be coming out of India. Okay, so one is the product opportunity, and then the other one, product meaning the design opportunity, and the other one is the manufacturing opportunity. All of these things would need the manpower, right? I mean, would need the human power. And this human power, I would put it as engineering and research. These are the two categories, right? So the point is the technology trends that we are going to be envisaging are the ones that are going to be shaping the India that we are all going to be witnessing. Okay. So what are the technology trends? There are 7 electronics growth domains that I am seeing. I'm sure you're also seeing that. We all know about the AI/ML. This is the killer app of the decade. So there are auto EV. We are all now experiencing the entire EV segment really progressing at a faster rate, both on the two-wheeler and on the four-wheeler side, right? And on the consumer electronics, I mean, we don't have to mention consumer electronics. Everything that we are touching has the electronic component, right? And telecom and wireless, I mean, we are going to be the people, I mean, who would be launching 6G and 7G research and things that are happening already, and in the medical and biotech field also, and on the energy and clean tech, and on the space and defense. So the 6 growth domains that we are seeing, AI and ML is going to be the underlying thing across all the growth domains. And this is going to be impacting, AI, ML is going to be impacting everything that we see in each of the growth domain that we are seeing. So the growth domain and then the product build can happen in any of the domain that I mentioned. And these are the ones that will be driving the growth overall for India. So over here, let's assume, I mean, what are the trends that we are seeing in the chip design? Again, I'm picking up a theme. There are 7 emerging trends that we are seeing in the chip design. Security is number 1. Custom chips are number 2. Architecture, we are now seeing the custom architectures. If you just take processor as the architecture, right? I mean, RISC-V is coming in a big way, which is really making the open core architecture, enabling multiple processor build, multiple controller build that would take the multiple product build forward, right? And then we all know the traditional x86 and then the other RISC architectures that we are just seeing. I'm just picking up processor as an example, okay? And with these processors being in the middle of it, right? We now see the vertical integration wherein, I mean, multiple chiplets that are driving the chip design scenario. Like, I mean, if you have just the processor on top of it, your A accelerator that would start sitting on top of it, your memories would start sitting. So all these things, the chiplets and vertical integrations are the ones that are driving the advanced packaging technologies. And communication and wireless functionality in every chip is becoming a trend now, right? And then for the interconnects that I spoke about, photonics-led interconnects that would start connecting the chips are the ones that are in the trend now, right? And then I did mention about the heterogeneous vertical integration. So this brings in multiple technologies that are getting integrated. Whatever that I spoke on the chiplets and advanced packaging, this is just a chiplets, each of the dialects that are getting connected. But on the heterogeneous thing, chip-to-chip communication also happens through the vertical integration. So these are the emerging trends, that we are seeing in the chip design domain. So now, given all the trends and given all the growth markets, right, and we are sitting in India, what kind of the opportunity that we are seeing in building these chips that would lead to the product? I'll just pick up some of the trends and then some of the markets and then show you some of the products that could be built. I just centered it around the RISC-V architecture. There are more things that we can talk also. If there are more questions on if you're specific about one of the domain and then picking up one as the growth topic, I can address that as well. Okay. Hopefully you're all following me okay. If one of you can say, am I going too fast or I'm going okay, Saurati, or any of you?
Yes, ma'am. All fine, ma'am.
All fine. Okay. Okay, good. And you're able to follow?
Yes, ma'am. We are able to follow you, ma'am.
Okay, great. Thank you. Okay. So now we did talk about a lot of opportunity. We did talk about the growth domain, but all these opportunities should lead into some business. Only then, we can see the Viksit Bharat, progressing India and everything, right? So I'm going to be talking about some of the business opportunity that you see on a day-to-day basis. This again has a large potential for product proliferation. We all know about UPI. I did mention about UPI, right? So UPI, you see left, right, center, the UPI voice box being there. As of today, this voice box related technology and the voice box, even the product is coming from China. This is a very, very easy product that can be built with ultra low power, tiny RISC-V processor. RISC-V processor is an open architecture. You just need a small GSM connectivity for this box, and then you need to embed the speakers. I've put a very, very minimal volume of 10 million. This is with this product. You can just imagine, right? How where you can deploy and how the product can hit the market, and you could start building a business out of this product idea. Okay. Now we'll go to the second product idea. So this is about the e-passport. So e-passport, today government is already talking about creating, like how we are having the Aadhaar. The e-passport is going to be a single kind of card kind of the thing, which will have a flexi electronics. So let's assume somebody creates a business case for this. This again can run with a tiny RISC-V, and this is going to be ultra low power. You need a small passive RF component, and this has to have some crypto component also. And if you make it an ultra thin package, this could be a flexible electronics made e-passport, and this could hit a volume of greater than 200 million very easily. Okay. So these are the products that could be built real time by any of you or few of you that has a real business potential. Okay. Now, next. We all know about DigiYatra, right? When we go to the airport, DigiYatra is really, really making our life easy. So there is a camera-based instrument that is sitting, right? I just picked up DigiYatra as an example. This could be installed at any of the places wherein face recognition could be used as a technique to screen and then to get you in. It could be at workplace, it could be at mall, it could be at any place, right? Wherever, if you need to have a secure entry, right? This again could be realized with multi-core RISC-V processor based, a small Android tablet and face recognition technique. You could come up with a small algorithm, and that could either be part of the chip, or that could be part of, you could pick up the chip that already has a face recognition coded, and both could be integrated to build this product. And I've again put a very, very nominal volume of 100K. Beyond 100K, there is a business opportunity. Okay. Drone flight controller. Again, drones are everywhere. I mean, we all have seen drone applications for smart irrigation or for the borderline security. But today I see drone as part of, I mean, you go to a wedding, I mean, drones fly left, right, center, taking all the camera pictures and stuff like that. And then with drones, there are fireworks, right? Fireworks are getting replaced, and then drones are the ones, I mean, that create all the fancy fireworks that we see in the sky. Point is, building drone flight controller and building drones could again be a very good business opportunity, wherein let's assume if you're just building a flight controller, this again can be realized with dual core RISC-V processor, some amount of the sensors, you need a communication module, put all the security related features. I've put again a very, very small volume of 100,000, and beyond 100,000 volume, you can create a good business case. BLDC fan controller, I mean, we all talk about this. Today, the fan controller chips would just need a simple RISC-V processor and a small Wi-Fi module. 100 million is a very small number, right? So point is, all the opportunities that I mentioned, there is a humongous business potential, and these products are easy to build, right? So this takes us as the job creators side of it. I just picked up some segments and some examples. I mean, you could extrapolate, and then you will be able to build more compelling products as well, right? Okay, now touching upon EV. I did mention that, I mean, EV is a very, very compelling growth segment. I've provided a tear down version of EV over here. So there is another business opportunity that exists, wherein you build the subsystems for the EVs, CCU, the cluster control unit, or motor control unit, or battery management unit, or portable chargers, right? I mean, today the GaN based chargers are most talked about, because a single charger can cater to laptop and phone and multiple other devices, right? I mean, gone are the days, I mean, wherein, I mean, you're carrying multiple chargers. But the point is, portable charger just by itself is a business, right? And all the subsystems that I mentioned here, again, is a business. I mean, you would be able to build the subsystem, bring all the products together, partner with the EMS company, and then you could become a small subsystem creator and subsystem provider for any of the EV OEMs, right? And then there are other subsystem opportunities that I have mentioned here for UPS inverters, for any of the white goods, or for any of the industrial applications, and for the charger infrastructures, and for renewable windmills, and then the renewable energy infrastructures, railways and data centers. Any of these places, you could identify the subsystem, build opportunities, and then you would be able to contribute to any of these segments. Again, Traintronics, I hear, is a very, very big opportunity. We all know how convenient is Vande Bharat. And within the train, there is humongous amount of the electronics that are going to get in to take care of the infotainment space, to take care of the train journey. The experience that they want to provide is very comparable with the flight journey. So all the infotainment and all the things that you're seeing, you are going to be witnessing in the train as well. This is, I'm hearing this actually a multi-billion opportunity. This is going to be the 10% of the budget is going to be allocated to improvising the feel that we are all going to be getting inside the train. Okay. So whatever I spoke so far gives you a perspective of where all the chip build opportunities that takes you to the electronic product build also. And we all know about India Semiconductor Mission. So this is the government body, and then this just got formed in the year 2020, 2021. And then there is the humongous incentive announcement that has happened by the government, $10 billion is announced. And you all see the people in the picture. I mean, I had the honor of being there when the policy got, and when the first Semicon India announcement happened also, and the inauguration happened. So the point is, all the things that I'm mentioning here, semiconductor fabs, display fabs, compound semiconductor fabs, ATMP, all these things, you would start seeing a lot of opportunities on the fab and the manufacturing side of it. Following the announcements, the plants that are listed are all becoming operational, or the civil work is happening and they would be becoming operational in the coming years. So whatever I spoke is the manufacturing opportunity. Now coming to the design opportunity, what government is doing is, for all the chips and then for all the electronic products that I spoke about, what kind of the incentives that they can provide to ensure that there are multiple semiconductor product companies that could be built out of India. So government is giving you money to start the company. So the 50% of the total expenses would be borne by the company. And if you have a good IP idea, or if you have a good product idea or a chip idea, you would be able to submit your proposal, and the proposals would get screened, and you would be funded by the government. So this is on top of the venture capital and other ecosystem that we are seeing, right? This shows that, I mean, government is really committed to ensure that the design ecosystem is the one that needs to get fueled properly. So all the companies that you're seeing over here are the ones that are already funded by government. There is a GLI 2.0 that is coming in. So if you have a good idea, I mean, go ahead and then submit the proposal, is how I would put it. So now, this is the most important thing that I wanted to touch upon. So for all the opportunities that I mentioned, so this again, the data, this is backed by multiple analysts. The requirement that we are foreseeing from now to 2030 in the coming 5 years is 1.25 lakh design engineers requirement is there. So this is electrical, electronics, and everything put together. And there are 10,000 manufacturing professionals who are required. And for all the drives that I spoke about, there is an excellent research opportunity that exists. So government has launched this program called Chip to Startup program, wherein there are 250 plus institutions are already supported. I'm sure GCT would be one of the institution, and you would be having access to all state-of-art EDA tools. If not, let us reach out. I mean, reach out to me. I'll talk to the professors and I'll see how you could be part of this program and how GCT could be provided the state-of-art EDA tools, which would enable you to become the industry-ready chip engineers. Okay. So there is a future skill program wherein, like how we are all studying electronics and communication, how I studied electronics and communication. Now electronics and VLSI is becoming a course, and this is already getting offered in 150 plus institutions, and master's programs are already there. So the point is to cater to the 1.25 lakh design engineers. What are we doing as a community? The electronics and VLSI program is already launched, is what I'm trying to tell. And I'm sure you are aware of the chip incentive. This is again a government initiative wherein all the EDA tools, Siemens, Synopsys, Cadence, ANSYS, these tools are already part of it. And government is partnering with multiple fabs to ensure if you have a good idea, the idea could be realized into taking it all the way up to tape out. So this is the company that I represent. I work for Renesas, and Renesas is a microcontroller company. We hold the #1 position on the auto microcontrollers. automotive is our biggest segment. I'm sure you're aware of Texas Instruments, NXP, Microchip. So Renesas is a Japan headquartered microcontroller company. Our play is in automotive, industrial, infrastructure, and IoT domain. In all these domains, I mean, you have a chip design and product development opportunity. So we provide reference design kits that would enable you to create the products that I mentioned, the multiple opportunities that I mentioned. You could use some of our boards and you will be able to build the products. I just wanted to touch on the segments that I show as the growth domain. We do have a play. We do have a play in auto, industrial, infrastructure, and IoT. So I just wanted to give you a message to all of you. You all need to understand that hardware is not hard, because I mean, a lot of people, I hear that, I mean, I would want to take computer science because software is cool. Hardware is not hard. Hardware design, chip design is more like a software design. I mean, here also you write code. I mean, this is similar to writing Python code, right? There are plenty of jobs. I already mentioned about the 1.25 lakh job opportunities in the coming 5 years. And the package is also pretty good. This is just starting package itself is greater than 10 lakhs. 10 lakhs is the bare minimum number that I have mentioned. And I would want and urge you to do a tape out before you graduate. So there are programs that are available. If GCT could become part of those programs, I mean, you all could do a tape out before you graduate. And again, for all the opportunities that I mentioned, there is a perception that hardware startups are hard. Hardware startups are not hard. And we will have to demythify that. Hardware startups require more money and more time, which is not true. This is same for both hardware and software. Any startup, the build goes through the same struggle and pleasure, I would say, which is very comparable. So don't buy into those myths of building hardware startups is hard and raising money stuff. There are success stories that I can talk through. Steradian got acquired by Renesas. This is RF company. Idea Forge is a drone company. This is already an IPO company. And Adverb is a robo company, right? I mean, bought by Reliance. So point is, there are multiple success stories on the hardware side as well. And this is the global semiconductor ecosystem. Every electronics engineer need to be aware of this. So I thought I'll just touch on this. So these are the manufacturing companies, TSMC, SMIC, Samsung, UMC, product design companies. I mean, I'm sure you're all aware about it. NVIDIA, IBM, ARM, Apple, Qualcomm, Broadcom, and IDM plus memory. This is Intel, Micron, and manufacturing companies, equipment for manufacturing, ASML, I'm sure you're all aware, ASML, Applied Materials, and for raw material companies, Air Liquid and all the companies, and for EDAs, Mental Graphics, Synopsys, Cadence, and IPs, ARM, Sevar, Rambus, Cadence, and Synopsys. Okay. So these are the companies. I'm sure you're all familiar with the companies. I thought I'll just pick up some of the companies and then just put it that way. I mean, you know that the opportunities are plenty. I'm just not talking. Okay. Okay. So this is little bit of my brag and picture, I would say. I used to be a day scholar while I was studying, and I used to be taking the cycle and then coming to GCT. And from that time onwards, I mean, cycle is one of my favorite commute. And this is, I have been associated with the chip industry. I passed out in 85, so this is almost 40 years. I've been doing chips that enabled multiple products. So the t-shirt that I'm wearing also is telling I have a chip on my shoulder. So I always have some chip. And the journey continues. It started with GCT, and I'm really feeling proud to be able to contribute to the India Semicon ecosystem and witnessing the golden era of opportunities, right? We have been waiting for this moment of all the announcements that you are all witnessing for years and years now. It is real and the fabs are all operational, chips are all happening, everything is happening in India. So this is the golden era, I would say. Okay. So my final message is, together, let's make new India electronics and semiconductor product nation. So, and in this journey, I mean, we are all together here, and we will definitely see a better and a greater India, I would say. Okay, so you all heard me okay?
Yes, ma'am. Yes, ma'am.
Okay, I stopped sharing. So you all can, whoever can come in the video can come, and then any question and every question is welcome.
Thank you, madam, for that enlightening session. Your insights have given us a deeper understanding of the semiconductor industry and its future opportunities. Now we open the floor for a 10-minute question and answer session. If you have any questions, please feel free to ask your questions. You can even drop them in the chat box.
Yeah.
Good evening, ma'am.
Hi, Vignesh.
I am Abhishek from ECE third year.
Okay.
And basically, one myth is that it's doing MTech is necessary for to enter into the VLSI domain.
Not really. I mean, you could do after BTech also, but MTech gets you to specialize things better. You are in electronics and communication now, right?
Yes, ma'am.
Okay, okay. So my only suggestion and request would be, look for the industry intern opportunities, and all of you connect with me in LinkedIn. And if there is anything that I can do, I mean, I'm pretty connected in the industry. I'll be able to connect you all. My industry internship is the one that is the most important thing. You all of you acknowledge that. And over there, I mean, you would, it really steers your interest better, is how I would put it, right? Doing masters is always good, okay, but if you want to get into industry immediately after BTech also, I mean, you can choose to do that. It doesn't hurt.
Thank you, ma'am.
Can I know what is tape out? Okay. Tape out is the process that gets the final chip database, the one that you create with all the things that you need to go through, right? There are multiple steps. Maybe I'll take a separate class, or I mean, you could let me know. I'll just walk you through. When you have a design, just from the idea, concept, all the way up to building a silicon and building a product, right? I mean, there are multiple steps involved. I could suggest some books. You could go through that also. The point is, tape out is the culmination of all the efforts that you put to realize the chip, right? I mean, first you have the spec is translated into a code, and then the code gets verified. After verifying, there is a way to implement, right? Like, I mean, you have you need to create a floor plan. You will have to place all the components, and then you realize the chip. Once the chip is realized, it is translated in a format that is consumable by the fab. So fab takes that electronic format, and then it goes through multiple steps in the fab, and then the chip is realized. So tape out is the final process. So these days, I mean, we transfer the data through all the, I mean, FTPs and through all the network transfer. Those days, I mean, we used to be, once the chip implementation is done, the data gets stored in a tape, real tape, and then that gets shipped to the foundry. And that's why it started, people started calling this as tape out, and then that continues to remain. Did you get it? Okay, question.
Ma'am, is there any open source tools to replace like paid version of cadence and synapses like this?
Open source
Like,
tools to replace?
yes, for cadence and synapses because we don't have access. Like, because we don't have access for EDA tools.
Yeah, there
We
are
need to
open
know.
source tools and everything, but EDA tools access, I'm sure GCT would be having. That's why you're telling maybe Saurati or one of you kind of volunteer, and then, I mean, send me the details. I mean, I will let you know how to apply. I'll share the links and everything. You could talk to your HOD, and they should be able to apply. Maybe it's already there and then you are not aware. You're all in third year, right?
Already there are only 13 systems cadence tools, so only 10 systems I know.
What?
We have access for 10 systems cadence tool now.
10 systems. Well, which tool you have access?
Cadence CDM, cadence tool.
Cadence EDA, right? So Cadence EDA you have access. Okay. And Cadence is an industry standard tool. So only 10 systems have the access. That's what you're telling?
Yes, ma'am.
Okay.
Sometimes the lab is full, so students want to know about any open source tool like Magic
Open
for
open
layout.
source tools are there. I mean, OpenLane, OpenRoad, those tools are there. But I mean, that can get you started, but it's always good to have access to, it's always good to acquire the access that you already have, right? I mean, whatever that you need to do to get it.
Okay.
Any other question?
Hello, ma'am.
Yes.
Ma'am, looking back, what advice would you give to your younger self when you were at GCT, ma'am?
I would say that, I mean, while I was at GCT, I was kind of too focused and too much of a first bencher, and I really wanted to be getting the outstanding credentials and everything, right? I used to be a too serious person. I looking, and I had a great journey also, but now thinking back, I feel that maybe I could have taken things little lighter, and maybe I should have had more fun, is how I would put it.
Ma'am,
Yes.
ma'am, you told there are business opportunities like drone controllers
Yes.
and.
Yes.
Is it better to do drone controller with embedded, like taking a processor, or how it related to VLSI, ma'am? By building a chip for especially for
See,
drone controller.
I touched upon drone because it's a product opportunity. Okay.
Yes.
So VLSI, because my talk, I just wanted to touch on VLSI, the chip part of it, and then on the semiconductor manufacturing part of it, what are the opportunities? I just wanted to provide a kind of glimpse of the opportunities. Okay. Electronic product, the reason I picked up drone is the fact that IdeaForge has become a IPO company already. It's an India-born company, and I'm sure you all know about Three Idiots, right? I mean, the IdeaForge drone was the one that you all had seen in the Three Idiots thing. Okay.
Yes, ma'am.
So the point is, I mean, their journey started at IIT Bombay over there, building a small drone, and that got featured in 3 Idiots also. Now they've gone all the way up to kind of making an IPO company, and then their UAVs have a lot of specialities and everything, right? And then this takes care of all the border security and things like that. So point is, there are such opportunities that are available. And then I did touch on the entertainment aspect also, because I mean, drones you see everywhere now in the entertainment
Yes.
space. If you pick up some use case that you think is going to be pretty exciting for whatever space it is, right? You will be able to come up with a drone that could cater to that space, right?
Okay, ma'am. Thanks, ma'am.
So embedded systems are everywhere. I mean, if you any of them, I mean, for instance, I mean, you would have a camera module also. So
Yes, ma'am.
some of the Renesas boards and some of the TI board, microchip, anything could have a play in the drone surveillance side of it, or anywhere that you see. Right?
Yes.
And these are off-the-shelf component that you can just pick up, and then you could build the product, right?
Okay.
Hello, ma'am.
Yes, Saurati.
Ma'am, please could you share few words regarding the experience at IMB?
IMB. Okay.
Yes, ma'am.
Okay. IMB was I did it as part of the executive MBA. Saurati, whoever is asking. I would put it this way. When did I do my? I think it was 2005 or during that time. Okay. By when I've already done one or two startup. I was in the middle of my second startup while I was at IIM. So I always had this thought of doing MBA. Like, I mean, I have to do my MBA. It was there as kind of the quote unquote unfulfilled wish or whatever. And when this opportunity came, and then when I started doing, my first experience was there are a lot of things that I was taught in MBA. I had already practiced. I had learned it through multiple startups that I did, right? So the learning that came out after the course was there are a lot of validation. Number one, that happened. Oh, okay, whatever you are practicing, okay, this is good because this is already getting validated by the quote unquote teaching, right? I mean, through the classroom teaching. That is one amount of the validation. And then the second thing is, then the conscious practicing started evolving. Like, okay, now that you know, oh, in this startup, I have done this way. This is validated by my executive MBA. Now I need to consciously ensure and practice that I am not dropping this. I'm doing this. So that's the kind of the experience that I had. And this time, because I again I already told, like, I mean, I used to be little bit of quote unquote too serious person at GCT also. During the exec MBA time, right? Like, I mean, I was consciously wanting to practice that. I mean, if there are some fun components, I should not be missing out on that. I should be part of it, right? That's what I was doing. Did I answer you, Saurati?
Yes, ma'am. Thank you, ma'am.
Okay.
Ma'am, recently you received an Young Women Achiever Award, ma'am. Please, can you walk us through that so that we'll know more about it?
Yeah. Okay. This is actually this award was given by VLSI Society of India. So this this organization is close to my heart. Like, I mean, this is like I've been. I'm sure you all would be knowing about the VLSI Design Conference. and then the VLSI Design and Test Conference, right? I mean, so these conferences are the ones, I mean, wherein from the college, it started almost around 85, 86 onwards. So right after the college, wherever I was in the industry, also I would be ensuring that I'm part of, I'm trying to submit the paper, or I'm part of these conferences, right? Because these are the ones, I mean, that bring the entire community together. Now, today, Saurati, Movisha, some of you have taken effort to bring all of us together in this platform, right? And so similarly, those are the conferences, I mean, that brings the global technologies and people in under one roof, and then, I mean, you get to exchange the ideas and everything. So that way, I've always been part of that body. And 2018 onwards, I have started holding the official position also, as a secretary. So over there, I'm recognized for the contribution that I have done to the community of VLSI and semiconductor, to see how the 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 awareness is created at all levels, right? Like, I mean, so we started creating multiple chapters. I've started becoming part of multiple regional chapters, and then spread the word about VLSI, spread the word about the hardware, and ensure that, I mean, you build more and more interest in the students' head. I mean, in the students, I mean, who would be even at the high school level, right? Like, I mean, I would go and I would tell them that, I mean, why hardware is important, why students should pursue electronics as a career, and stuff like that. So that is one part of it, that is for the community. And then the other part of it is the on the startup side, like, I mean, they acknowledged my journey of creating multiple successful silicon and electronic product startup, wherein this created meaningful contribution for the industry, for them, for the people around, and people who have learned with me, and everything. That is kind of overall, Saurati. And it's such a great feeling to get it from the organization that is close to your heart, right? It's always.
Yes, ma'am. Thank you, ma'am.
And these things motivate you to do more, right? Okay. Any other questions?
We'll ask the participants if they have any questions,
Okay.
ma'am. Participants, if you have any questions, you can just post it in the chat box, or you can unmute your mic and ask to ma'am. Ma'am, I request you to please stay in the call even after the attendees leave, ma'am.
Okay.
Yes, ma'am.
No problem. Any of you have question? Otherwise, I mean, I'll let you know, Saurati. I mean, most likely it's on April 4th. I'll let you know in the afternoon. And you tell whether you students and HOD all will be available, then I'll come over.
Yes, ma'am. Sure, ma'am.
Did you find it interesting? Or you need next click details on this, more questions, anything, let me know. Feel free to put your comments either in the chat box or anywhere, or you open the mic and tell. Okay. What mindset should we have? Tell me, Himesh, you can unmute and talk. You're unable to unmute. Okay, no problem. Okay. No problem. Okay, so for the manufacturing mindset, let's assume we pick up a product. I mean, because we have been talking so much about drones, I'll just take drones as an example, right? So there are what kind of the mindset? So I'll just address the mindset as a topic. When you're building the prototype, you would be running around and then you would be getting the components, and somehow you will ensure that you build the product and then you will make it work also, right? And then that would be the, and you would feel very happy about, okay, I got my product working. I mean, that's a first accomplishment that needs to be celebrated. Everything is good. But now the next step is you will have to start working on reducing the bill of material, because I mean, first your focus was just to build the product, right? Next, your focus needs to be, is this the cost at which you build the product, would it make sense if you need to be building in volumes, right? So you will start looking at the bill of material. You would start looking at every part, how much it costs, and then is there an alternate part that I can pick up, and will I still be able to build the product that will still meet my functionality, right? I mean, so that is, so what does that mean? I mean, you're bringing in the cost sensitivity, right? I mean, first is the functionality part of it. You just want things to be working. Second, you're bringing in the cost sensitivity. Once the cost sensitivity you brought in, everything is working fine. Now you will start looking at where do we manufacture and how do we manufacture, and what kind of the volume, and who are my customers, right? So my advice is, first step, while you're building the product itself, you will have to have in your head who is the customer. Do not build a product if you don't have a customer. Your product could be a cool product. I mean, your product is the most innovative product, but if you cannot sell the product, do not build, right? That's the number one mantra that I would say, right? So mindset, number one, first is, first time you think that you want to create and build something, fine. Just to kind of get that appetite fulfilled, build a cool product. But before even building, I mean, you will have to start thinking about who is my customer, start creating the partnership with the customer. It could be, it could just be some friendly person who would want to test your product, right? So these are the things, I mean, that comes on the way, like how I mentioned about the executive MBA experience, right? Like, I mean, some of these things you will build on the way of building the company, building the product, going through the startup journey and everything. Anything else? What skills should students focus on to prepare for careers in the semiconductor industry? Number one, Madhimalar, I would say, focus on your fundamentals. Fundamentals should be learned with ultra diligence. Okay. And when you are getting into chip industry, practice diligence. This is not the industry wherein, okay, I create another software version and then I create a patch and then I make things work. No. In chip design, the moment the tape out that I mentioned, once the data is given to fab, it is done and dusted. You will have to pray. Once the chip comes back, it has to work, right? It is just not about praying. You should have put all the diligence to build the chip so that it comes right the first time and working right the first time. Okay, so a lot of diligence are required. Okay, I'm not trying to scare you here. Build that as a practice, right? Lot of good books. I mean, you could Google and then check. I mean, you send me a note in LinkedIn. I'll be able to send you some of the book names. Okay. Anything else? Time for dinner?
Yes, ma'am.
Food irukuma hostel?
Yes, ma'am. Ilanalu will take in.
No problem. There was another question. Let me answer that. What should be the chatler? Somebody had a question. Let me answer that. Aryabhatta one, right? Glad to be there. Let me just can I know what step or how India is number one? Physical designer is but I don't know tools. What programming language could I get? What mindset? Very good books I'll recommend. Yeah. See, GPU, if you need to build GPUs, right, I mean, you will have to have a good aptitude for architectures. Start with matrix multiplication, right? I mean, understand all the basic AI algorithms, architecture aspects of it. And then you will have to, that is just on the specification level. And then there is a spec needs to be translated to code needs to get into verification. So you will have to start understanding the protocols, and then it gets into the chip implementation aspect of it. And while you're implementing the chip, what are the things that are required? Diligence, all the things that I mentioned. I think I'll have to have one separate talk about the chip design aspect. I mean, that should give you a lot of things. What I mean, right? I mean, okay. Anything else?
There are no further questions. Shall we wind up?
Okay, I'm good. Thank you, everyone. Look forward for seeing you all. All the very best. Stay in touch. Stay in touch. All the very best.
Yes, ma'am. That was truly an inspiring session. On behalf of GCT Talks and everyone present here, I extend our heartfelt gratitude to Ms. Chitra Hariharan for taking the time to share her journey and expertise with us. We hope this session has provided valuable takeaways for all aspiring engineers and future innovators. Thank you all for joining us, and we look forward to seeing you in our upcoming GCT Talk sessions. Have a great evening. I request all the attendees to leave your mail IDs in the chat box. Make sure you put your mail IDs in the chat box so that the update about the further sessions will be sent. Ma'am, I kindly request you to please stay back in the call, ma'am.
I'll stay back. Thank you, everyone. Look forward.
Once again, I request all the attendees to post your email